The ultimate bearing capacity of pile is the maximum load which it can carry without failure or excessive settlement of the ground. The bearing capacity of pile depends on the type of soil in the area, the method of pile installation or pile construction, and also pile dimensions. Cross-section area and length of pile are also important parameters. So, when we look at a pile, there are two sources of support. We have a pile. A support is the support coming from the end point, the soil beneath the pile. And the second type of support is coming from the friction between pile and soil surrounding that pile. So we have a skin friction force. Again, the friction, it's coming from the friction between pile and soil surrounding that pile. And then we have support coming from endpoint. So we call it end or point force. The ultimate bearing capacity, the ultimate bearing load is when we add endpoint force and a skin friction force together. We can also have different types of piles. So, if we have a pile sitting on a strong soil, this is a pile and we have a strong soil with high capacity, high strength, and our pile is sitting on bedrock, for example. We have a larger force at the end point compared to the friction. So there is the depth of pile is really small. So we have a small skin friction, but a much larger endpoint force. So in this case, endpoint is larger than a skin friction force. We will call these types of piles end-bearing pile. Then we also have piles where we have a higher length for our pile, and the soil beneath the pile is weak, so we have a small endpoint. In this case, QS or skin friction force is larger than endpoint force. These types of piles are called friction piles. But in general, QU is when we add end or point force to friction force. So again, the ultimate bearing load. This is QU, ultimate vertical bearing force is equal to QS, or ultimate skin friction force. This should be S. skin friction force, or QS, and QP, or point or end force. So ultimate is when we add end force and a skin friction force together. If you remember, uppercase Q is equal to lowercase q times area. So a skin endpoint force is equal to end bearing capacity times end area. This is end bearing capacity, and this is end area. And then we have QS, which is Fs times As. Fs is a skin friction capacity, and As is side surface area. And that's how we can calculate the ultimate bearing capacity or ultimate bearing force for a pile. So when we have a pile, in this lecture, we will look at a cylindrical pile or a square pile. This is length of pile, and then we have width of pile or pile diameter. Or radius of R. When we talk about end area, this is end area. So end area, or AP, is pi r squared if we have a cylindrical sample, a cylindrical pile, or it's b squared if we have a square pile. This is a square, and here we have a circle with a radius of r. End area for cylindrical pile is pi r squared, and it's b squared for a square piles. Then side area is the side surface of pile. If you open your cylindrical or a square pile, along the length, you get a rectangle that has a length of L, and this side is equal to the circumference of this circle, which is 2 pi r. Or for the square, if we again open it along the length of pile, we have L this side and circumference of this square, which is 4b. So this is the side surface area for a cylindrical pile. As is 2 pi r times L, And for a square pile, AS is 4B times L. So again, for a cylindrical pile, AS is 2 pi r L. For a square pile, AS is 4B L. We also need to find, so we are trying to calculate ultimate bearing force, which is equal to QP plus QS, and that's QPAP plus FSAS. So here you have the formula for AP and AS. We have the formulas to calculate point capacity and a skin friction capacity for driven piles in sand. And this is provided in NCHRP report 393, and the formulas are provided here. So end bearing capacity is equal to 1000 times, this is SPT resistance, a square root of N value or NBPF, which is the number of blow counts for the SPT data, and you get your QP in kilopascal. For a skin friction capacity or FS, you can use this formula. Again, all of these is for driven piles in sand. Fs in kilopascal is equal to 5 times N value to the power of 0.7. So you can calculate Qu as Qp plus Qs, which is QPAP plus FSAS. And then you can calculate allowable bearing capacity by dividing ultimate bearing capacity by a factor of safety. So we have a fully embedded precast concrete pile, 15 meters long, driven into homogeneous sand. So since it says sand, we can use formulas provided in this report. The pile is a square in cross section, so we have a square pile. $15 meters long, and it's 0.3 meters by 0.3. The standard penetration results near the vicinity of pile tip. So N value or N BPF is 16. Calculate the ultimate point force QP. And QP is point capacity times end area. Point capacity is 1000 times a square root of N value. And when we have a square, pile AP is B squared. The final answer, or QP, is equal to 360 kilonewton. We also have a pile load test, which is when we have a test pile. Using a hydraulic jack, load is applied. Then we have load versus settlement. So this is load, here we have settlement. When load is applied, with an increase in load, we will observe an increase in settlement. When we remove the load, some of that settlement will be recovered. So this is how much settlement is recovered, and this is our permanent or net settlement. So the net settlement is total settlement minus elastic recovery. The pile load test is the most reliable method for determining the load carrying capacity of a pile. A fully embedded precast concrete pile 10 meters long is driven into a homogeneous sand layer. Pile is a square, so we have a square pile. It's 10 meters long and it's 0.4 by 4. 0.4 meters times 0.4 meters. N value or SPT resistance is 25. So we have an N value, NBPF or SPT resistance of 25. The question is asking us to calculate allowable bearing load using a factor of safety of 3. Allowable bearing load. So allowable bearing load or force is equal to ultimate bearing force divided by factor of safety. Then ultimate bearing force is equal to ultimate end or point force plus ultimate skin friction force. Endpoint force is equal to endpoint capacity times endpoint area. A skin friction force is equal to a skin friction capacity times side surface area. So we have length of pile 10 meters, factor of safety 3. We have a square pile. SPT resistance 25 and width of the cross section is 0.4 meters. Since we have a square foundation, end area is B squared and side area is 4B times L. B squared 0.16 meters square. AS 4BL 4 times 0.4 meters. And so this. We also have a driven pile in sand, so we're going to use these two formulas to calculate point capacity and a skin friction capacity. Thousand times a square root of N value or NBPF or SPT resistance 5000 kilopascal. A skin friction capacity 5 times N value to the power of 0.7. And QU or ultimate bearing force is equal to QPAP plus FSAS. That's ultimate vertical bearing force. The maximum load that you can apply without failure. And then we get allowable bearing force by dividing ultimate by the factor of safety. So this is another example, and you can solve this problem by yourself just to practice.